Hello everyone, welcome to Algo Pandit. Today we are going to take a look at the Leetcode question number 332, Reconstruct Itinerary. So this question is a very famous question and it's been asked in multiple companies like Uber, Facebook, Amazon, Microsoft and Twitter. So let's take a look at this. Given a list of airline tickets represented by pairs of departure and arrival airports from to reconstruct the itinerary in order. All of the tickets belong to a man who departs from JFK. Thus, the itinerary must begin with JFK. So, the starting airport is JFK. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order when read as a single string. For example, the itinerary JFK LGA has smallest lexical order than JFK LGB. All airports are represented by three capital letters. You may assume all tickets form at least one valid itinerary. One must use all the tickets once and only once. Let's take an example here. So we have the input, which is a source to destination, array of source to destination. So this is Munich to LHR, JFK to Munich, San Francisco to SJC, and LHR to San Francisco. So the output will be JFK, Munich, LHR, SFO, and SJC. So it's easily we can understand that this is a graph algorithm, right? Graph problem. And here we are talking about directed graph because it's clearly saying that the source will be Munich and the destination will be LHR. So there is a direct relationship between Munich to LHR. It's a one-way relationship, right? But there is always you can have another another direction from LHR to Munich, but either way. So this is going to be a directed graph. All right. So what are the requirements here? So the requirements are, so given a list of itineraries, right? So this is for a person who started from JFK. So the starting point is JFK, and if there are multiple itineraries for the same source and destination then we need to return back the smallest lexical order. So the given example is JFK to LGA and JFK to LGB. So LGA has the smallest lexical order than LGB. So it should return LGA should come first before LGB. So that is a constraint here, right? So how do we solve this? So the first and foremost, we need to construct the graph. For that, we are going to use the adjacency list. So before we are creating the adjacency list, as we need to take care of the lexical sorting, so we can sort the tickets in a lexical graphical order based on the destination. Sort based on the destination. All right. So that will make our life simpler. And then we can create the adjacency list graph, and after that we can perform a DFS traversal. So to be precise, this is going to be a post order DFS traversal, and then we can collect all the source airports, and then we can return the result back. All right. Let's start writing the code for this one. So we have the tickets, which is input. Let's do a sorting on it. Tickets dot sort AB A of 1 dot local compare B of 1. So this basically is going to sort the given input in a lexicographical order based on the destination. Okay, so now let's create the graph. list ticket of tickets. Then we need a map to hold the graph, and this is going to be a directed graph. So if graph of ticket, so this is going to be, let's do a destructuring on it. Source, destination, graph of source, graph of source equal to, so initialize it with an empty array if that if that source is not already exists in the graph. And now graph of source push the destination. All right, so now this loop will build up the adjacency list graph. What next? Let's define a local variable to hold the answer, the result array, right? And let's define the function dfs, which will take origin as a starting point. So starting point will always JFK, because this is for one single person who starts from the JFK. So that's already given in the question. So DFS is JFK. So what we need to do here? So first we need to see whether the origin exists in the graph. So let's do a while loop on it. Graph of origin, and also graph of origin. I can't get this one. Origin dot length, right? Okay, let's do one thing. Let's extract this into, okay, let's leave it for now. Okay, so now we have to do DFS of graph of origin. Let's get the first destination, right? So we already did the sorting, lexicographical sorting. Then we can do a shift, right? So when you do the shift, it's going to give us the first lexicographically smallest destination from the list of destinations, and then we can do a DFS on it. And once we've done that, let's push it into our answer. Okay, so this will build up the answer. So the only problem here, it will be, this will be in a reverse order. So what we need to do is, let's reverse the answer. Okay, so let's take an example of this one. So the graph structure is going to be MUC. MUC has LHR as one of the destination. That's it. It has only one destination. Now let's take a look at JFK. JFK has MUC also. Yeah, so that's the only one destination for JFK. Now let's take a look at SFO. SFO has a destination of SJC, and let's take a look at LHR. Okay, that LHR has a destination of SFO. Alright, so this is our adjacency list. So we consider all the vertices, all the sources in the graph. Okay, so when you iterate over it, right, so the starting point will be JFK. So to start from JFK, then it will go to Munich. From Munich it will go to LHR, and then it will go through SFO, and then the final point will be SJC. So the answer will be JFK, Munich, LHR, SFO, and SJC. As it is a post order traversal, we are pushing the last vertex first. So that is SJC, and then SFO, and then LHR, and then Munich, and then JFK, and then finally we do the reverse. It will give the correct result. Assume we have multiple data element, multiple destinations, right? So let's take this example. JFK SFO, JFK ATL, SFO ATL, ATL JFK, ATL SFO. Let's try to create the adjacency list. So JFK has destination SFO and as well as ATL, and SFO has ATL as well as, okay, there's only one, okay, and ATL has JFK and SFO, right? So JFK, SFO and ATL. SFO has ATL as the destination and ATL as JFK and SFO. As we'll be sorting this by default when we get the input. So let's sort this out. Let's sort the adjacency list, right? So ATL and SFO, ATL, and this is the correct one. Okay, fine. So now what happens here? So we start from JFK, right? So from JFK we start the DFS traversal and then we shift the first element. So that means ATL will be the first element. Then we'll take ATL, then we'll take the first one. So ATL will be JFK. So JFK will come back and so JFK the next iteration. So JFK will be SFO. So let's do the SFO here. SFO will come back to ATL, right? And then it will go to the next ATL element, which will be SFO again. So the traversal will be JFK, ATL. The person will come back to JFK and he will go to SFO. Then again he will go to ATL, and from there he will come back to SFO. So yeah, so this will be the path, and like I mentioned, as we do post-order traversal, it will be in a reverse order, and then finally when we return the answer we have to reverse it and then we have to return it. Okay, so let's try to run it. So JFK, okay, let's try. Okay, there is only one course. Let's try to add this example as well. Let's try to run it. Yeah, so looks like we are getting the correct output for all the given input. Let's try to analyze the complexity before we submit the problem. So we can see this one is going to be order of n log n because it's a default sorting algorithm. It will take order of n log n, and this loop is going to be order of n because we are going to iterate over each and every ticket. And here we are going to do DFS algorithm, DFS traversal, which will be order of v plus c, vertex plus edges, right? Order of v plus c. So the final complexity will be, and this is again order of n because we are doing the reverse order. So final complexity will be order of n log n, okay, plus order of n plus order of v plus e plus, and then again there is an order of n, and which will come to order of n log n, which is because that is the because that is the top one, right? The rest everything is like smaller than order of n log n. But yeah, we can say that it is order of n log n plus order of n in a worst case complexity, and space complexity will be it will be the graph complexity, right? So graph basically in a worst case scenario it create n entries in the graph and the vertex basically, so it will be order of p, which will be the space complexity here, okay? And plus we can say that DFS traversal, which is recursion, we can say it will be another order of p as well, order of v plus c as well, okay? So that will be the space complexity. Alright, So as now we have calculated the time and space complexity, let's try to submit the problem. Okay, so I have been already working on it with multiple solutions, and so this is the best possible solution which I could come up with, where it's 108 millisecond and faster than 41% of JavaScript submissions. All right, I hope you understood the problem. Thank you for watching. We'll see you later. Thank you.